Good morning to all of you. I think I am audible. So today we will start about design of flexible pavement. Okay, just a minute. So today, basically, we will discuss about very basic parts of the flexible pavement design. So for the design purpose, basically, we need a IRC code, and that IRC code is IRC 37 2001. So first thing is you have to collect that code. After that, we can proceed for the design. But in this class, we will only discuss about the very basic portions of the design. That is, what are the basic requirements and what are the different parameters which we have to consider for the flexible pavement design. Now, the flexible pavements have been modeled as a three-layer structure, and stresses and strain at critical locations have been computed using the linear elastic model. So basically, there are different types of layer in the flexible pavement, but whenever we will design in a layered analysis, there are different type of analysis. In a layered analysis, in that case, basically, we will consider the flexible pavement as a three-layer system. So what are these three layers? So first one is subgrade layer, then we will consider the base layer and then surface layer. So considering these three layer, we will analyze the model. Now, to give proper consideration to the aspects of performance, the following three types of pavement distresses resulting from repeated or cyclic applications of the load are considered. Now, why cyclic applications of the load are considered over the pavement? Because in the pavement condition, you cannot put compressive force, or you cannot put tensile force. So the force applied over the pavement surface is different. So basically there are some rolling load or repetitive load because vehicles tires are moving over that road or rolling over the road repeatedly. So whenever we are testing or we are finding the failure life of a pavement, in that case we need to consider the repetitive cyclic load. Okay, so basically, by using that repetitive cyclic load, we will find that after how many revolutions, some cracks are generated over the pavement surface. Now, vertical compressive strain at the top of the subgrade, which can cause subgrade deformation, resulting in permanent deformation at the pavement surface. So, because of the action of this cyclic load or repeated load, what happens, some vertical compressive strain will generated and some compressive tensile strain will generated. Now because of this compressive strain, some type of deformation will cause, and that deformation is permanent deformation, which we will discuss later on, and which is in generally called rutting failure. Now, horizontal tensile strain or stress at the bottom of the bituminous layer, which can cause fracture of the bitumen layer, and this fracture of the bitumen layer is called fatigue cracking. And another type of pavement deformation is there, that is pavement deformation within the bituminous layer. Now, while the permanent deformation within the bituminous layer can be controlled by meeting the mixed design requirement, thickness of the granular and bituminous layers, and suitable subgrade material, and using a analytical approach to calculate all the strains and stress which we can make into limit. Now, for calculating tensile strains at the bottom of the bituminous layer, the stiffness of dense bituminous macadam layer with 60 by 70 bitumen has been used in the maximum analysis. Now suppose this is the tire, so this is a repetitive load, so over this different type of strain will be generated. The compressive strain will be generated at the bottom of the subgrade or at the top of the subgrade layer, and because of this some deformation will cause and that deformation would be permanent. Now because of the tensile strain which will be beneath the binder course, for that some crack will be generated and that is called fatigue failure. So these are the critical locations in the pavement where failures can be occurred. Now these two important terms, fatigue criteria and rutting criteria. Now bituminous surfacing of pavements displays flexural fatigue cracking if the tensile strain at the bottom of the bituminous layer is beyond the certain limit. So see here the tensile strain is generated below the binder course, okay, below the binder course or above the surface or granular base course. So in this case, if the tensile strain is excessive, in that case some crack will be generated and this is fatigue. Now the relationship between the fatigue life of the pavement and the tensile strain in the bottom of the bituminous layer is obtained by using this formula. Now the thing is this fatigue life means after how many revolutions that fatigue will happen. This fatigue life of the bitumen is related with the tensile strength and elastic modulus of the bituminous layer. So in this equation, whatever equation is shown over there, in this equation, NF is the allowable number of load repetitions. So that is basically total number of load repetition to control fatigue cracking, and E is the elasticity modulus of the bituminous layer, and this is epsilon T is the basically your fatigue or fatigue cracking, that is the tensile strain generated over the bottom surface. So see here tensile strain generated over the bottom surface and elastic modulus is related to the allowable load repetitions of the flexible pavement, and this is called fatigue criteria. So that means using this formula you can find out up to how much revolutions or up to how much repetitive load a flexible pavement can carry without the failure. Now fatigue cracking is due to the buildup of tensile strain at the bottom of the asphaltic concrete layer. Pavement is considered fail if 20% of the surface has cracked. Just remember this thing. Pavement is considered failure if the 20% of the surface has cracked. So next is rating criteria. Now here also that writing criteria is related to the total number of repetitions of the load or cyclic load. Now here this rating criteria, that is total number of cumulative standard axle to produce the rating, and this here for the fatigue cracking, your fatigue cracking criteria is 20% of the surface has cracked, and for the rutting cracking that criteria is basically 20 mm depth. 20 mm depth. Okay. Now, NR is the number of cumulative standard axle to produce rating of 20 mm. Now here it would be Ez or epsilon Z is the tensile strain and Ez is the vertical subgrade strain, and rutting failure is due to the buildup of excessive compressive strain at the top of the subgrade layer. Now another thing you have to remember here, whatever fatigue cracking criteria and rutting cracking criteria, that is formula is given, that formula is basically applicable for the 60 to 70 grade your bituminous material. Basically whatever value is given, that value is given, that is 2.21 into 10 to the power minus 4, that 3.8, and these values basically these values changes within the changes of the material characteristic, within the changes of the subgrade properties and other things. So basically if we just summarize the formula, that formula would be NF is that is proportional to or 1 by Et into 1 by capital E. Okay, so basically that thing will change depending on the different pavement conditions. So see, if we discuss about the different loading conditions or different layer system, in that case, if that is the wheel load, in that case, your fitting and rutting criteria, just a minute. Okay. So So basically this is the asphalt surface course and this is the binder course, and beneath the binder course that tensile strain will be generated, which will further affect the fatigue of the pavement surface. And if that is the granular subgrade, now beneath the granular subgrade, here the compressive strain will be generated and that will ultimately affect the rutting criteria. So basically whatever rutting is there, that is the basically your permanent failure. Now one thing you can see that why subgrade is very much important for the pavement, because see here that compressive strain is generated just above the subgrade course. Now because of this, if your subgrade is weak, in that case because of that compressive strain, that subgrade will be got damaged, and because of that, that failure in the subgrade will be eventually shown over the surface and it will be act as a pothole. So whatever potholes you are observing over the road surface, basically they all are the types of the rutting, and because of the subgrade failure in maximum cases they happens. Okay, so for these reasons this subgrade course is very much important for the flexible pavement design. Now another thing is design traffic, that how much traffic or what is the value of the traffic which you have to consider for your design purpose. Now the method considers traffic in terms of the cumulative number of standard axle. Cumulative number of standard axle means how much total that number of repetitive loads are there. Okay, for the standard axle load. Now this standard axle is considered as 8160 kg, or you can consider this as like similar to 8 ton to be carried by the pavement during the design life. Now, this requires the following information: initial traffic, that the traffic growth rate during the design life in number of years, vehicle damage factor, and distribution of commercial traffic over the carriageway. So these are the information which you need for the design of the flexible pavement. Now let us discuss about this all these things. Now CVPD is commercial vehicle per day. Now, initial traffic is determined in terms of commercial vehicle per day. What is the total number of commercial vehicle per day? Now, you remember in case of our traffic volume count, we have our PCU, passenger car unit. Our standard was passenger car. So, we consider passenger car as a one, and respect to the passenger car, we have calculated what is the total PCU of other vehicles. But in case of design, our standard is your commercial vehicle of 8160 tons. So based on the commercial vehicle load, we will convert all the other loads into the commercial load values. Now, for the structural design of the pavement, only commercial vehicles are considered, assuming laden weight of 3 tons or more, and their axle loading will be considered. Estimate of the initial daily average traffic flow for any road should be normally be based on 7 day to 24 hours of classic volume count. So you have to traffic volume count you have to do, and that volume count should not be in the PCU terms, but it should be in terms of classified volume count. Classified volume count means you have exact informations about the different type of vehicles which are running over that portions of the section of the road during that particular time. Now, in case of new roads, traffic estimates can be made on the basis of potential land use and traffic on existing routes in that area. Now, for that survey, you have to conduct origin and destination survey to find out what should be the potential number of users or future users could be present or could be using that particular new route. So that is our initial traffic. Now traffic growth rate. Traffic growth rate can be estimated by studying the past trends of the traffic growth that you are studying for at least 5 years of the traffic growth trend, and you can estimate what is the traffic growth, average traffic growth, and you can apply to find out your future traffic using that traffic growth rate, or by establishing economic models, different econometric models, different models you can generate to estimate what is the traffic growth rate. So how you can generate some econometric models? Basically, that principle is a topic of research. You have to find out different models. For example, you can find out some relationship between the population growth and your traffic growth, and based on that relationship between the populations and the traffic, you can find out what is the future growth rate of the vehicles within your area. Now, if adequate data is not available, it is recommended that an average annual growth rate of 7.5% may be adopted. Now, next thing is very important: design life. That is, for how many years you have to consider the design life of your pavement. Okay, so there are different design considerations for different type of roads. As you know, there are national highway, state highway, express highway, etc. So for the national highway and state highway, design life is considered as 15 years. For expressway and urban roads, it is considered as 20 years. And for the other roads, it is considered as 10 to 15 years. Now, another important term is vehicle damage factor. It is very important. Now, vehicle damage factor is a multiplier for converting the number of commercial vehicles of different axle loads and axle configuration to the number of standard axle load repetitions. So basically that is equivalent to the PCU in case of your pavement design. So in this case also you are converting the number of different axle load configuration into the standard axle load configuration with a multiplier and or factor that is called vehicle damage factor. So it is defined as equivalent number of standard axle per commercial vehicle. Now the VDF varies within the axle configuration, axle loading, type of terrain, type of road and form region to region. As PCU changes from different vehicles to vehicles, different based on different road sections, whether it is based on in the urban section or in rural section. Similarly, based on different factors, your vehicle damage factor will also be changing. So basically your vehicle damage factor is a multiplier for converting the number of commercial vehicles of different axle loads and axle configuration to the number of standard axle load repetitions. Now, the axle load equivalency factors are used to convert different axle load repetitions into equivalent standard axle load repetition. So, for these equivalency factors, refer IRC 37/2001, where you can find out ready-made VDF value for different type of axle load configurations. So another important factor is vehicle distribution factor. So initially it was vehicle damage factor. Another one is distribution factor. That is how much vehicle is distributed along the different paths. So a realistic assessment of distribution of commercial traffic by direction and by lane is necessary, as it directly affects the total equivalent standard axle load application used in the design. So until reliable data is available, the following standard can be assumed. So vehicle distribution factor is how much commercial vehicle is distributed among the different lane. Okay. Now for the single lane road, traffic tends to be more channelized on a single road than a two lane roads, and to allow for this concentration of wheel load repetition, the design should be based on total number of commercial vehicles in both directions. Then two-lane carriageway, the design should be based on 75% of the commercial vehicles in both directions. So in the single lane road, see what happens. Suppose this is a single lane road. So here all the vehicles will be concentrated or forced to move a particular direction. Okay, so for these reasons, whatever vehicles are there, their load or impact of the loading would be higher in the single lane road. So for these reasons, whatever wheel load repetitions you are getting, that repetitions for both the directions you have to consider. But the two lane road, what happens? The number of concentrations of the vehicle will be reduced than from the single lane road. So therefore, in this case, you have to consider only 75% of the commercial vehicle in the both direction. Now for the four lane road, that further reduces, and design should be based on 40% of the total number of the commercial vehicles in both direction. Now for the dual carriageway roads, for the design of dual two-lane carriageway roads, it should be based on 75% of the number of commercial vehicles in each direction. For dual three-lane carriageway and dual four-lane carriageway, the distribution factor is 60% and 45% respectively. So these data are required when enough data about the vehicle distribution factor is not available with you. So in that case, you can follow the standard to find out the vehicle distribution factor. Now another thing is for the design of the road section in IRC, that is Indian Road Congress, uses standard method or CBR method. So previously that was only CBR method. Now that CBR method is transferred to modulus of subgrid reaction. Okay, and after that, based on that modulus of subgrid reaction, you will find out what is the different layer thickness. Now, why CBR test is conducted? CBR test is conducted to know the different properties of the or strength parameters of the different layer. And how modulus of subgrid reaction is calculated? Modulus of subgrid reaction is calculated based on the plate load test, which we have discussed earlier. Now, if the subgrade for the subgrade for the lesser than 5% CBR, if the subgrade has lesser than 5% CBR value, in that case, that relationship with the modulus of subgrade reaction would be 10 into CBR. That is, whatever CBR value is there, you multiply it with 10 and you will get exactly the modulus of subgrade reaction value. Now, if the CBR value is more than 5%, in that case, your value would be 176 into CBR to the power 0.64. So, if you use this equation for a subgrade value more than CBR value more than 5%, in that case, you can directly calculate the modulus of subgrade reaction. Now, why modulus of subgrade reaction is calculated in the indirect way? Why they do not prefer the direct test? Because that modulus of subgrade reaction is time consuming test and it takes huge resources, and CBR test is very much ready-made test and it takes very little time to complete the CBR test. Therefore, that relationship has been established to find out what is the relationship between the CBR and subgrade reaction. Now, for the granular subbase and base course, these are the formula. Okay, where E2 is the composite modulus of subbase and base course. In that case, you will find out the modulus of subgrade reaction E using this formula, and E3 is the modulus of the subgrade MPa and H is the thickness of the granular layers. So these are the formulas. Using these formulas, you will find out what is the modulus of subgrade reaction using the CBR value. Now these are the different temperature value, and based on these different temperature, that is 20, 25, 30 degrees Celsius, 35 degrees Celsius and 40 degrees Celsius, and TBM is dense bituminous macadam. Okay, it is SE is asphalt concrete, SE asphalt concrete, dense bituminous macadam. 80 by 100 is 80 to 100 grade bitumen. Here similarly asphalt concrete or dense bituminous macadam 60 to 70 grade bitumen. Similarly that is bituminous macadam of 80 to 100 grade and bituminous macadam to 60 to 70 grade. For that, for different temperature, these are the modulus of the subgrade reaction. These are the modulus values. And another important factor is your Poisson ratio. That is also important. So for the subgrade course, there are different Poisson ratio values for the subgrade course and for the bituminous layers, which you have to follow for your design purpose. So these are the standard modulus Poisson's ratios values for the design of the flexible pavement. Now another thing is, now you need to compute, first you need to compute the design traffic. So how you have to compute? N is the cumulative number of standard axle to be catered for the design in terms of MSA, that is billion standard axle. Here 365 it denotes the total number of years. Here R is the annual growth rate, N is the design life. So if you want to design for 15 years, in that case N would be 15. If you want to design for 10 years, in that case N would be 10. A is the initial traffic in the year of completion of the construction in terms of number of commercial vehicles per day. So what are the commercial vehicles? The vehicles weighing more than 2 to 3 tons, that are the commercial vehicles. So for the design purpose we only need only the commercial vehicles. So A is the initial traffic during the start of the or completion of the construction. T is the lane distribution factor and F is the vehicle damage factor. So considering all these things, you will compute what is the design traffic for your design of the pavement surfaces. The traffic in the year of how you calculate traffic in the year of completion, that is A, because whenever that project will take time, suppose 2 years, 3 years, or 5 years, or 10 years, like that. So how during the initial period of time you will get to know about what would be the traffic after the completions of the project. So in that case you need to find out that traffic using the growth rate. So here you will find out A is P is the number of commercial vehicle as per the last count. So before the starting of your project you will take one traffic classified traffic volume count, and in that case P is the total number of commercial vehicle as per the last count. Commercial vehicles, or in that case you can call it is a truckload or a laden weight, and R is the, that is your growth factor, and X is the number of years between the last count and the year of the completion of the construction. So suppose you have taken a project which, and for that project you have taken a survey on suppose 2001, and you are assuming that your project will be completed on 2007. So total in between the total year is 6 years. So here X would be 6. So like that you can calculate what is the total number or initial traffic in the year of completion of the project. Okay, is this portion is clear? I'll not take that class because today's class is little bit complicated. I'll continue the next portion in the next week. So before that, you just go through all these things so that all these things are clear to you. Otherwise, we cannot continue with the design portions of the different component. So up to this, whether it is clear to all of you or not, is it clear? Is it clear to everyone? So if it is clear, I want to ask you some questions. See, in the initial traffic, it is written here, commercial vehicles are considered assuming laden weight of 3 tons or more. Okay, that is you are considering a laden weight of 3 tons or more as a commercial vehicles. But in other case, in the next case, it is written as you are taking a load of 8160 kg for your laden weight standard axle load. So what is the difference between these two? Let me find out this thing. Okay, here see 8160 kg. Here in one instances it is written as 8160 kg as a standard axle load, and in another instance that is another instance it is written as commercial vehicles of more than 3 tons are used for the that your design purpose. So what is the difference between these two things? So basically the difference is 8160 kg, that is your standard axle load. So in the design of the flexible pavement, you will not consider any vehicles which weight is lesser than 3 tons. Okay, so you have to count only the vehicles whose weight is more than 3 tons. And within that 3 tons, there will be different type of vehicles. Some weight may be 3 tons, some of the weights may be 4 tons, some have maybe 5 tons, 8 tons, 10 tons, 12 tons, okay, 15 tons, 16 tons, like that. So here there are different type of loading conditions for different type of vehicles, and within that range 8160 kg or nearly 8 ton is your standard load. Okay, so for the vehicle damage factor you will have to consider one factor, and that factor is calculated based on the 8160 kg. So that is the difference between both these two things. Okay, so for this design of the flexible pavement, you will not consider any type of vehicles which weight is lesser than 3 tons.